Okay, in this short video I'm going to show you how I had to go at optimizing the fuel map tuning of my Chinese diesel heater to get it burning most efficiently. And if you're the sort of people who want to have a crack at that in a cost-effective and pragmatic way, this may be of use. And what I mean by that is we all know, because it's day one at nursery school, what you do is you buy a gas analyzer and you shove it up the exhaust, blah, 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 blah. But personally, may not be the only one in the world, I really don't want to spend more money on a bit of kit to tune it than the heater itself cost me. Okay, now there's loads of people out there with gas analyzers who think I'm wrong, but that's my take on it. That's how I'm proceeding forward. No need to mention gas analyzers in the comments. Okay, now full transparency, like everyone in the world who has only installed one or two of these heaters, I am no expert, okay? There's plenty of people on Facebook think they are, but I'm not one of those people. Okay, so what I'm proposing is that it might be possible to tune these diesel heaters reasonably optimally without a gas analyzer, but instead using a simple multimeter with a temperature setting and a cheap K probe. And we'll look at, I've got the kit and we'll look at that in a bit more detail. But what I'm using to validate that is Hess's law and Hess's equation. And many of you out there will know that Hess was the geezer. He was the dude who established the relationship between a chemical reaction and how much heat was given out or taken in. So essentially you can in theory calculate how much energy in terms of heat will be given out from these heaters if they burn in a perfect combustion or a hydrocarbon rich combustion, like overfueling some people colloquially call it, or a lean combustion where there's too much oxygen. Okay, and I think I can demonstrate that, and that's what I'm going to show you in a minute. However, there's some massive caveats around this. First of all, there's loads of literature I read on this, and it just seems like actually there is no such thing as a perfect combustion. Even in the most sort of sophisticated kit, you will never get a perfect combustion. So you're always going to get a little bit of carbon monoxide and carbon being produced. But what we're aiming to do is to bring it right way down so it's just not an issue. The other thing is on the lean side, what it was, a lot of the literature is saying that in terms of lighter hydrocarbon alkanes such as diesel and kerosene, 28-second heat oil, all that sort of thing, they're all basically the same family, that it's unlikely that you'll get incomplete combustion through too much oxygen. The exceptions are in the presence of a catalyst, you can do that. And the equation I'm going to show you in a minute is a catalyzed equation. However, what it did say is other inefficiencies kick in, which could also affect the amount of heat you're going to get out of your heater into your van. Okay, and the big one is, in terms of overfueling, is when there's a forced air system, which of course the diesel heaters are, because you've got a fan blowing the air into the combustion chamber. Okay, it's not like a natural combustion like you'd have on a gas fire or a hob. And in those circumstances, if you over-oxygenate it, you're not getting excessive oxidization of the kerosene or the diesel, but what instead is happening is you're forcing air out through the flue, or in this case the exhaust, so you're losing heat that way. So that was a little bit of a complication, but I thought actually it doesn't really matter, does it, through my method, how you're losing, whether it's through Hess or through excessive heat being forced out through the combustion chamber and the exhaust. Now look, this is where I'm keen to get a bit of feedback, because I'm no expert. I'm not a chemical engineer. My primary degree was in mechanical engineering, and yeah, I did do some thermodynamics and enthalpy calcs and all that sort of years ago. And not enough to be an expert on this, so I obviously welcome your input. And that degree was actually an awful long time ago, and no need for comments in there saying no shit. Right, okay, let's get into the nitty-gritty and see what I'm doing. Okay, so just before we go into the van and play with the heater, let's look at Hess. So here are the entropy values that we're going to feed into the equation. And here is first the Hess equation for a theoretical perfect burn, and putting those values through, it comes out with a minus 5083 kilojoules per mole. So it's a minus, it's an exothermic reaction, which is what you expect because heat is being given out. Okay, so now let's compare that against a theoretical rich burn, overfueling as it's sometimes colloquially referred to in the forums. And you can see there that what we didn't have before, we've now got carbon monoxide, CO, it's the stuff that kills you. Don't think we want that. And also carbon, C, which is the soot that soots up your heater, and we definitely don't want that either. But in those circumstances, we actually get a reduced exothermic reaction now, 4,937 kilojoules per mole, and there is less heat has been given out. So finally then, the theoretical lean burn or over-oxygenated, which we know is unlikely without catalyzation, you get 4,446 kilojoules per mole, and again carbon monoxide and carbon, but as we know that's very unlikely, but we'll get heat reductions in other ways. And so the method that at last I'm about to show you in the van should, in theory, have some validity. So what I did is I thought I had to find a way, and I messed around with lots of things, and what I came up with, which seemed to work quite well, is I used what's called a K thermocouple plugged into my multimeter. Okay, now loads of people are going to have these because they build their own vans, and most of them will have a temperature setting. The actual K probe, you buy these on eBay about £5. Okay, so it's no money. If you haven't got a multimeter with this on, with the temperature setting on, you can just attach probes to the end of the thermocouple and look at the resistance. However, not ideal because it's not a linear sort of one-for-one change of resistance equals change in temperature, and the multimeter deals with all that. So, but these aren't expensive these days anyway, are they? Not like gas analyzers. Oh, I said I wasn't going to mention gas analyzers. The better it's tuned, the more heat output you'll get, which will result in less carbon monoxide and carbon, etc., etc. Okay, so that's it. Now, right, so how did I go about it? Well, what I did is I shoved the end of my thermocouple up the heat output inside my van, and then I had it running, and then I moved the probe back and forward until I saw the highest point temperature on my multimeter, and I clamped it at that one. Now I must say, when I first started thinking about this, I was going to try and measure the heat output by just measuring the temperature of the body, the heat exchanger, with one of those infrared thermometer gun things. But the more I thought about it, I thought you got heat radiating out of that. It might cause, it might be more prone to error than putting a thermocouple actually in the constant airflow itself. I think I'm probably right on that, but again, we welcome any comments from you guys. Okay, all right. So that's the starting point. Now it may be your heater, you've just got it, and you can't get to fire up at all, it's just white smoke coming out, because that's what happened to me. Because we all know you don't buy these things from the manufacturers, you buy them from box shifters in China who get a batch in, they shove it in with bits of crappy tube and that sort of thing, flog it off to you, and for all you know, they might have bought a batch of heaters that were destined some high altitude place in China, and it's not going to work from day one. So when you see people on Facebook saying, mine works straight out of the box and I've had it go for 3 years and I've never touched settings, you should never touch settings. Well, good for them, but some of us, we have to touch settings, and some of us want to touch settings because we want to optimize it in any case. All right, and but what I would say is, if yours is working, make a note of your settings, because if things go wrong, you can put it back to it, and that is the last patronizing bit of nonsense I'm going to come up with now. Right, okay, so if you have got a problem and you can't go in, try using these settings. That's what I did when I first kicked off. I went onto Facebook and got some settings. I'm not sure if it's these ones because it's about 6 years ago now, but this will get you going. I can see from the figures that they're close to what I've got on my heater now, so that should get it fired up. If it doesn't, you've got something else wrong with your heater. Okay, so do a screen grab of that if you need it. Now I'm going to go into the van and start playing. Okay, so these are the initial settings I put into the controller. Now it's hard to make these videos short and punchy, and I've made the assumption you guys know how to get into the controller and adjust the fuel map. But in case you don't, there's a link at the top now you can click on, and I'll put it again at the end of the video if you want to watch this through first. Okay, so that was my kickoff settings. Alright, and the idea is we do a tune at the lower speed range, and then we do a tune at the higher speed range, and we rely on the algorithm of the controller to set the settings between those two. I had intended to start with a lower fan speed than that, but 1450 RPM was the lowest I could get it. And of course what I should add is I've got the smaller body 2 kilowatt heater with a 0.16 mil pump, but I'm absolutely sure this principle will work for the 5 kilowatts if that's what you've got. So having done that, I fired up the heater on the lowest setting, 1.0 hertz, and when the speed of the fan dropped down after it got up to temperature, I left it for another 10 minutes to stabilize, then took a temperature reading which came out at 126 degrees centigrade. I should add now that every time I made a settings change, either to the fan or the pump, I waited another 10 minutes for it to stabilize. So this took quite a long time, okay, but I left it 10 minutes for the temperature to stabilize. So now I say, well, let's assume we're running it a bit rich. We'll increase the fan speed to 1550 and see what happens. But after 10 minutes, the temperature actually dropped to 123 degrees centigrade. So actually, I'm thinking it's not too rich. It might be a bit lean. So then I dropped the fan speed back down to 1450 and increased the pump speed up to 1.1. And after 10 minutes, by coincidence, it was still 123 degrees centigrade. So it looked like, by good chance, the initial low speed settings I had were the optimum fuel mix, and so I locked those at 1.0 hertz pump and 1450 RPM fan. Ran it for another 10 minutes to let it stabilise, and though it didn't get up to 126, it did get up to 125, which basically locked into my mind that, yeah, we got the right kick-off setting at the lower end of the range. And then moved on to the upper range. So back to the main panel on the controller and crank up the setting to 5.0. Leave it for 10 minutes, and then I saw I had a temperature of about 199. It flickered between 199 and 198. So then I thought, well, maybe we're running it a bit lean. Let's richen it up a bit by dropping the fan speed. Left it for 10 minutes, but the temperature did actually drop to 196. So I think it's not too lean, maybe it's too rich. But to be sure, I took the fan speed down another 100 to 4400, left it for 10 minutes, and sure enough, the temperature did drop further to 189 degrees centigrade. So I thought it's definitely not running too lean, maybe it's running a bit rich, so I reset the fan speed, fan speed back up to 5000 RPM and dropped the pump down to 4.8 just to see if we get a little bit less juice going in. And sure enough, the temperature actually went up again to 203 degrees centigrade. So I tweaked the pump speed down to 4.6 hertz, and sure enough, the temperature went up to 205. So we're going in the right direction here. So we're getting close, I think. So I took the pump speed down one notch to 4.5, and the temperature went up a little bit more, fluctuating between 206, 207. We'll give it the benefit of the doubt and call it 207. So I took it down one more notch to 4.4, and this I thought was quite interesting because the temperature kind of plummeted 4 degrees. So actually it was between 4 and 3. It was fluctuating between 203 and 204. So clearly I think we just hit the right setting on the trial before. So I cranked the pump high speed back up to 4.5 again and leaving it there. So that's my final settings with the tuning. Tuned to the bottom end, tuned to the top end range, and trusting that the algorithm in the computer will do its best job to get the fuel mixes right between those two. Okay, so that's how I went about trying to optimize the fuel air mix ratio across the spectrum on my Chinese diesel heater without the use of an expensive, I won't mention the GA word. I will actually. If I had a gas analyzer, would I have done a better job? I don't know. Certainly, you know, the thermochemistry theory works. It stacks up and it seemed to play out on the ground. Time will tell, but the initial results seem very good. I've run that heater right across the spectrum from 1 up to 5. No hint of a white smoke at any point, so it seems to be burning clear. One thing I did check is that when I was down at 1 hertz, because that is quite a slow spit of diesel into the burn chamber, but the body was getting up to the required temperature. I had the 2 red bars, so all is good there. So yeah, if you want to have a play, have a go. Oh, yes, if you do need help on how to get into controller to mess with your fuel settings, There'll be a card at the end of this video. You can click on how to do that, along with a couple of other. I've got a video on how to pair your remote if you want to do that, and how to pair more than one remote. Perceived wisdom is you can only have one remote paired. There is a way of doing multiple remotes, that's on there, and also a text switch, how you can turn your diesel heater on from your mobile phone using a text switch. So that's great if you're coming back from a walking, or get it fired up 20 minutes before you get back to the van, something along that. Right then, heater nerds, thanks for watching. Hope this has been of interest and maybe generated a bit of thinking. If you can see where I might have got this very wrong, please drop some comments in there, because I'm a bit of a fan of John Dewey and Bertrand Russell, the godfathers of critical thinking, and that's all about following the evidence and looking for reasons why you're wrong, not why you're right. But if you do, please give me the evidence. Just because your mate down the pub says it can only be done with a gas analyzer, well, he's probably saying that because that's the only way he's done it. But it might be that is the only way to do it, okay? But let's see the evidence. Anyway, hope it's of interest.